So hi, this is Mike again, and as I've been teaching networking and subnetting for IP4, I've created a series of spreadsheets to help explain what's going on. The first spreadsheet was base conversion, to go from base 2 to base 10 and base 10 to base 2. You've got to know how to do that. So before you try to watch this video, if you don't understand that, you need to go back and watch my video on base conversion. And I'll put a link for it in the description and at the top of this video up here right now. The next thing I did is I talked about subnetting in terms of breaking the address up on 8-bit boundaries. Since IP4 addresses are 32 bits in length, we might have the first two numbers of the IP address be network and the second two be host. So we'd have 16 bits of networking and 16 bits of host. And doing it on an 8-bit boundary is pretty easy, and I have a video on that. So if you have not watched that video, you need to watch it before you watch this one. And then this one, we don't have to subnet on an 8-bit boundary. We can do it in an arbitrary position anywhere in this IP address. So the first thing I've got here is I've got an IP address 200.45.100.67/28, and the /28 is describing the subnet mask. And I talked about that in the previous video, but we'll go through this. We need to get the subnet mask, and we need to know where our network bits are and where our host bits are. And since it's not a multiple of 8, it's going to be in the middle of one of these numbers. So the first thing we're going to do is take that /28, and I've actually got this set up over here on this tab, and I've got 28 network bits out of the 32 bits. So every time I need to write down that subnet mask. So every time when I'm trying to write the subnet mask, every 8 bits is a 255. So if I say 255 dot, well, that's 8 of my 28 bits. I've got 20 left. So then that means I can get another 255. But now, so I've got 8 bits here, 8 bits here. Now I've hit 16 of my 28 bits. I've got 12 left. So as long as you have 8 or more, you keep writing 255s. So now I've got 24 of my 28 network bits, and I've got 4 left over. So what that's telling me is this part of the subnet mask, some of this is going to be network, and some of this is going to be host. We've got 4 bits left. So if I break this down into binary by doing my 1, 2, 4, 8, 16, 32, 64, 128 bits, I've got 4 leftover bits. So that's going to be a 1 here, here, here. That's 4, right? So I had, this is 24, 8, 16, 24, 25, 26, 27, 28. Well, that's all my network bits. So the rest of this is going to be 0. So that is the end of my subnet mask. Once you've satisfied all the ones, the rest are 0. Now, what this number is right here, I've just got to add up the value of these bits. So the 128-bit is turned on, the 64-bit is turned on, the 32-bit, and the 16-bit is turned on. And if I add those together, it adds up to 240. So my subnet mask is 255.255.255.240. Now, a lot of times, the networking problem, they will give you the subnet mask. They will just give you this 255.255.255.240. So if I'm given the subnet mask here, then I don't have to go through converting the /28 to the subnet mask, but that's how we do it. It adds up to 240. Now the other thing, and in this technique of subnetting, we're going to use what's known as the magic number technique for subnetting. what we're looking at right here is the dividing line. In fact, I'll just grab this and copy it and paste it. The dividing line between my network bits and my host bits is right here. And on your piece of paper, you should actually draw a line right here. And then in addition to that, you're going to take that first number to the left of the dividing line and put a circle around it, because that is our magic number. And having that magic number makes subnetting on an arbitrary bit position easy. It makes it very easy. So all you're doing, your magic number is that last network bit of the subnet mask. So this is the last bit, so my magic number is going to be a 16. And you'll see why in a minute. So I'm going to go back to my other sheet, and I need to note that my magic number is the 16-bit. So what do we need to know about our network? Well, when you're subnetting, when you're given an IP address with a subnet mask, we want to know what network we're on, what is the first computer that can be on that network, what is the last computer, our host on that network, what is the broadcast, and what's the next network. Well, the magic number is going to make this trivial. It's going to make it very easy, but first we've got to find out what our network address is. Now, if you remember from the previous video, the way you get the network address is all the host bits are turned off. Now, if my subnet mask, remember that subnet mask was on that last octet, on that last number here, my subnet mask was 11110000. And remember I said you want to draw a line between the two, and you want to circle the number to the left, because that's our magic number. Okay, now I want to take that 67 and put it in binary. So I'm going to put 67 in binary right here. So if I have 67, can I get a 128-bit? No. Can I get a 64-bit? Yes. Okay, so if I have 67, I just subtracted 64, and that's going to leave 3 left. That's going to leave 3 that I have not accounted for. So with the 3 that are left, I cannot get a 32. That bit's going to be turned off. I can't get a 16. That's going to be turned off. I can't get an 8. I can't get a 4. I can get a 2 and a 1. Because right here, I can get the 2-bit. I subtract 2. That's going to leave 1. And then I subtract 1, and there's nothing left. Okay? So this is the binary of 67. So how do we get the network address? All host bits off. So that means I take the network bits, which are to the left of my dividing line, leave them unchanged, but these 4 bits are on the host side of my dividing line, so all I do is turn those bits off. What am I left with? I'm left with the 64-bit, which means this computer is on network 64. Because remember, you just turn off all the host bits. Once your subnet mask tells you where the dividing line is between, where do we divide it? Between network bits and host bits. Once we know that, we map out the binary of the IP address and just turn off the host bits. So we're on network 64. So that's the first thing I needed to know. I needed to know that I was on network 64. So the network for this computer is 200.45.100.64. It's computer number 67 on network 64. All right. So now, here's the wonderful thing about the magic number method. Once you know what network you're on, the magic number tells you how wide your networks are. So this magic number says that each and every one of these networks with this subnet mask is 16 IP addresses wide. So all I got to do is take my current network plus the magic number. So that is 64 plus 16. My next network is .80. 64 plus 16. Add the magic number to your network number. You get your next network. And if you want to look at that, I mean, if you want to look at that in binary, here's network 64. Here's network 80. See, network 80 is going to be the 64-bit plus the 16-bit. It's got different network bits. But you don't have to look at it in binary. The only thing you have to worry about is once you've got the network number, you add the magic number, you get the next network. Now, everything else is trivial. We know that all three sets of these numbers right here are networks, so they're never going to change. This might change. But here's all we got to do. My network number is 64. You always take your network number and add 1 to get your first host address, because it's one more than the network number. So if I'm on network 64, first host is 65. Broadcast address. All I got to do now is back up 1. So if my next network is 80, I back up 1, and that is the broadcast address for network 64. So what is a broadcast? A broadcast is where you have all the host bits turned on. So if I'm on network 64, and I turn all the host bits on, if you add that up, that's going to be 79. 64 plus 8 is 72, 76, 78, 79. I didn't have to do this in binary though. All I had to do is once I had my network number, I got my next network number by adding the magic number. Then I back up 1 for the broadcast, and then the last host is 1 less than the broadcast. So here's what I needed to know. This network starts at 64 and ends at 79. And the magic number tells me how many IP addresses I have. There's 1. 65 through 78 is 14 addresses. And then here is my 16th address. So I've got a total of 16 addresses. That's what the magic number tells us, is it tells us because we have 4 host bits, 2 to the 4th power is 16. That's how many IP addresses there are on that network. Now, you can never assign the network address to a computer, and you can never assign the broadcast address to a computer. So these two are unusable by computers. Everything in between can be used, can be assigned to computers. So that is the magic number method. Let me reset things here, and we will do a different problem. And through the magic of pausing my video, I've reset to a new IP address. This time we have 222.22.22.148, and it is a /27. So the first thing we need to do is get the subnet mask. So I'll jump over here. I've got 27. Remember, every 255 you write is 8 bits of the subnet mask. So since if I write these 3 right here, each one of these is 8. 8, 16, 24. That gives me 24 bits from the 255 group. So once again, everything's happening in this last octet. And I've got 3 bits left over. So in this case, I'm going to go 25, 26, 27. The remaining 5 bits of the subnet mask are all going to be zeros. So first thing we do is, once we figured that out, is we put our dividing line between the network bits and the host bits, and we circle the number to the left. So this time my magic number is 32. So with this subnet scheme, in other words, I'm saying in this subnet scheme, my IP address, my networks are 32 addresses wide. That's what the magic number is telling me, because there is that dividing line. Let's go back to my other tab. It's 32 for the magic number. What is my subnet mask here? What did these 3 bits add up to? So that's going to be 128, 64, and 32, and those will add up to 224. That is the answer. That is my subnet mask, so it's going to be 224. So my subnet mask is 255, that's 8 bits, 255, that's 16, 255, that's 24, and then this 224 right here is the last 3 bits. So now I know that my subnet mask for my network is 255.255.255/224. So that's the first thing we needed to do, is be able to convert the /27 to the actual subnet mask. Now, once again, if they give you both of these, you're not worried about it. Now, we also got my magic number. My magic number is going to be 32, and here's my dividing line, okay? Everything on this side is network, everything on this side is host. So to figure out what network we are on, I have to look at this number right here. All of this number is network because I got a 255. All 8 bits of that are network. All 8 bits of this is network, because remember, 255 is all 8 bits turned on. That means every single one of these bits is network. Every single one of these bits is network. Only the first 3 bits of this is network, and the rest of it is host. So I need to convert 148. I need to convert that 148 to binary. Well, I can get a 128, so I have to subtract 128 from the number, and that leaves me 20 left over. So I cannot get a 0, a 64, I can't get a 32, I can get a 16. Oh, look at that, my line's not straight. Oh, that's better. So then I have to subtract 16, and that's going to leave me 4 left. So can't get an 8, I can get a 4, and a 0, and a 0. So this is 148 in binary. Now the only reason we did that is to see what the network bits are. So the network bits are 100. And to get the network address, you turn all of the host bits off. So my network address is 128. Or more specifically, my network address to get the full IP address of the network is 222.22.22.128. That's my network number. Computer number 148 is on network 128. All right, that's great. Now we're done, basically, because all we have to do is take our magic number. If this is network 128, the next network starts at 128 plus 32. That's going to be 160. It's going to be 222.22.22.160. What's the first host? Take the network number, add 1. So since these are all 255s, they're never going to change. First host on that network's 129. The broadcast, all you do is you back up 1 from your next network, so the broadcast for network 128 /27 is going to be 159, and then the last host on this network is going to be 158. So the network starts at 128, goes all the way to 159. The next network starts at 160, because 160 is going to have a different set of network bits. 160 is going to be this. Here's this is network 128. If I was to just look at the network bits, this is network 128. If I turn on these bits right here, if I add 32 to it, that's going to give me 160. So my next network is 160 because it no longer has the network bits 100. Because the broadcast for this network is 159, which would be 100, and then all of these are turned on. This is 159. You add one more bit, you add one more to it, and it turns on the 32-bit, and all these are turned off, and that's a different network. So this is on network 128. This is on network 160. So the magic number, once we know that dividing line, then we can take that IP address right there, and all we care about is the network bits. And the network bits are 128. So once we got the 128, we add the magic number to get the next network. Now I've got my bookends. This is one end. This is the other end. Everything else is in between. What have we got in between? We start at 128 for this network. 129 is the first host. The broadcast is one less than the next network. The last host is one less than the broadcast. So the only thing we have to do in binary is figure out what network we're on. All right, let me set up to do one more. All right, so I have an address, an IP address of 211.11.42.65/29. So let's get the subnet mask for /29. So remember, every time you write a 255, that's 8 bits. There's 8, 16, 24. Now we started with 29, and we've written 24 of them. 8 plus 8 is 16, plus another 8 is 24. So we got 5 left. So here's 25, 26, 27, 28, 29. So the last 3 bits are going to be 0. I need to draw my dividing line between the 8 and the 4, because that's where the 1 changes to zeros. And then I need to circle that number to the left. So my magic number is going to be 8. Now what do these bits add up to? Well, I'll let you do it, but if 4 bits added up to 240 and we turn on one more bit, that's going to be 248 is going to be my subnet mask. So my subnet mask for /29 is 255.255.255.248, and I can put that right here. So we got the information we need now, and my magic number is 8. So that's the reason we draw out that subnet mask, is to figure out where the dividing line is, so we know what our subnet mask is, and we know what that magic number is, the dividing line between network and host. All right, so now this subnet mask is telling me all of the 211 is network, all the 11 is network, and all the 42 is network, because those are 255s. So it's going to be this all the way down. Okay? In fact, it'll be the same here. But we got to look at the 65 here, because this subnet mask is telling me some of the 65 is network and some of it is host. Now, where was my dividing line? It was right here, and my magic number is 8. All right, so we got our dividing line right here between the 8-bit and the 4-bit. Magic number is 8. Now I've got to look at this 65 to see what part of it is the network bits and what part is the host bits. So 65 is 0. I can get a 64. So 65 minus 64, that leaves 1. So since I have 1 left, that's going to be 0, 0, 0, 0, 0, 1. So how do I get the network number? I just have to turn the host bits off. In fact, I could have stopped turning this into binary as soon as I hit that dividing line, because I know these are all going to be turned off to get the network number. But anyway, let's just go through with it. So my network number is going to be 0. The 64-bit is on. Everything else is off. So I am on network 64. This computer is on network 211, 11, 42, 64. My next network is 64 plus 8. 64 plus 8 is network 72. We've only got 3 host bits, so these networks are smaller. They've only got 8 IP addresses each. So if that's my next network, now I've got one bookend. I've got this bookend. Everything else comes in between. First host is 65. The broadcast is 1 less than the next network, and the last host is 70. So the computers that I can assign to this network are 65 to 70. 64 is the network number, cannot be assigned to a computer. 72 is the next network, and 71 is the broadcast where all of the host bits are turned on. So this is subnetting. Now, every example I gave you was in the last octet, which means you're going to have a /25 or higher. The highest it can go is 30 because you got to have at least 2 host bits. So this would be /25 to /30. This works exactly for all those cases. And let me do one last one. I'll do a /25 just so we can see how that looks. All right. So let's say we have 205, 45, 37, 136 /25. So first let's get the subnet mask, and you just get a piece of paper and start writing 255.255.255, and that's 24 of my 25 bits. I've got 1 bit left here. So this part of the subnet mask is going to be 1. That's 25. The rest of these are going to be 0. So my dividing line is right here between the 64-bit and the 128-bit, and my magic number is going to be 128. So if I add these up, that means my subnet mask is going to be 128 because I only had 1 bit to add up. All right, so let's get the subnet mask onto the other page, 255.255.255.128. And my magic number was 128. Now it's a coincidence in this case that the subnet mask and the magic number are the same, because in the other examples they were not. Now, that tells me that all of these 3 numbers right here are network, because it's a 255, a 255, and a 255. So these are going to be the same all the way down. Oops. Let's see. I've got this. Let's just put this all the way down. Now we got to look at that 136. Some of that 136 is network. Some of it is binary. Where's my dividing line? It's right here. So we need to do the binary of 138. So the 128 bit's going to be turned on, so that's 138 minus the 128 bit. That's going to leave, I'm sorry, 136. I'm trying to do the wrong number. There we go. Let me get this fixed real quick. So that's going to leave 8 left. It's going to leave 8 left. So the 64 bit's going to be turned off, the 32, the 16. The 8's going to be turned on, so that's minus 8, and we've got nothing left. So these will all be 0. So to get the network number, I zero all of these out. All the host bits are going to zero out, and we bring the network bits down, which happens to be a 1. So that means we're on network 128. So also a coincidence in this example. I'm on network 128. Okay. How do I get the next network? Well, you take your network number and add the magic number, and you're going to get 256. But here's the thing. You can't store the number 256 in 8 bits. So it's actually, I've overflowed this. Once I get to 255, it's like an odometer. Once that rolls to 256, that means this number needs to go up by 1, and then we're on 0 right there. So my next network in this case is actually 205.45.38, because I would have had a 256 here. Now the 256 is okay, because when you get that 256 for adding it to the magic number, that means the broadcast is still 1 less. That's 255. And the last host is 254. And the first host, we take the 128 and we add 1. That's 129. But since we can't store 256 in 8 bits, this has to roll over to the next number and become a 0. And that 37 has to turn to 38. It's just like if I have the number 99 in our numbering system, and I add 1 more to it, it becomes 100. So when I get to 255 here, 256, that means it's actually a 0, and this next digit up has to get 1 larger. So my next network is 205.45.38.0. My broadcast for network, my network is 205.45.37.128. My broadcast is 255. My last host is 254. My first host is 129. So if you look at this range right here, 136 is definitely on that network. So that is how you do subnetting when you're borrowing bits in the last octet. It's the same idea if it's happening here. It's a little bit different. I'm going to make another video where I show that. And the best way to do this is to practice. It's not hard. You just have to practice. You get your subnet mask, and when you're getting your subnet mask, that gives you your magic number and gives you that dividing line. So once you have that dividing line and your magic number, you're home free. Because now we take that IP address and just look at the network bits. In this case, there's only 1. But you know, if my dividing line was down here, I'd have 4 network bits, and I'd only be looking at these to get the network number. If my dividing line was right here, I'd only be looking at these 2. If my dividing line was way down here, I'd be looking at these 6, and my magic number would be 4. That would be really small networks. But in this case, we had a /25, which means our dividing line was right here, and our magic number was 128. And then we figured out what network we were on by taking the 136, because some of this is network and some of this is host. The dividing line tells us which is which, and then we just strip off all the host bits to get the network number. And that is going to do it. If you like these kind of videos and you want to know more about subnetting, please like and subscribe. Thank you very much.